Assalamu alaikum everyone, I'm Afzal Badsha, and today in this video I'm going to discuss the database normalization, and also I will discuss in this video the dependencies, how the attributes depends on each other, and also the anomalies. For example, if we want to update data in any database, but we update data in one location but we don't update the data in another location. This happens due to the non-normalization, and if the data is scattered and it is not well engineered during creating the database. Data normalization, this is usually done to avoid the dependencies and also to avoid the anomalies. And will also discuss the different type of joins to gather data, to categorize data, or to collect data from different type of tables. When we depend dependencies, the functional dependency means when any attribute functionally depend on any other attribute. For example, here the x is functionally depending on y, or we can say that y is determined by the x. So the x is called the determinant because it is going to determine y, and y is called the dependent. And in example, you can say that, for example, we are talking about any student, then the name and addresses and his birth is determined by the registration number. So registration is determined, and all the other attributes are called the dependent. In the tribal functional dependency, it means that if x determines y, where y is a subset of x, it means that all the instance of y will be within the x, because x is the subset of y is the subset of x. All the instances of y are within the x. Non-trivial dependencies holds when y is not the subset of x. It means that the sum of its elements will be there in the x, but not all the elements will be there in the x. And the next one is the complete non-trivial dependency. This means that we take the intersection of x and y, then its result will be null, will be 0. This means that there is no common attribute, no common instances between x and y, which will be called the completely non-trivial dependencies. Anomalies means that some type of mishandling, you can say some type of mishandling, some type of errors, some type of mistakes in database. The first one is the update anomalies. Actually, the anomalies occur due to the if the data is scattered, if the database is not well organized and it is not well engineered, then such type of anomalies occurs. For example, the update anomalies, we having the student data in 3 different locations, but we update the data in 2 places but not in the third place, then this will be called the update anomalies. And such like the delete anomalies, we delete the data from one place but not delete it from the second, third, or any other position, then this is called the delete anomalies. And the next one is the insert anomalies. It is the same such like the update and delete anomalies, that we insert the data in the one table in one location but we don't copy it into the other location where the data is present, and this will be called the insert anomalies. So how we can remove these anomalies, how we can remove the dependencies between the data? To remove the dependencies and to remove the anomalies, the normalization is used. Okay, the 4th type of normalizations which we are going to discuss in detail in this video are the first normal form, the second normal form, the third normal form, and also the Boyce-Codd normal form. So what is first normal form? In the first normal form contains non-atomic value. For example, in our relations, we are going to store data, but one cell contain more than one values. We can say that when we put more than one names in the one tuple, as you can see that the course is an attribute, the content is also an attribute, then you can say that in the programming, contents contain more than one value. It contains the Java, it contains C++, and also in the web you can see that it contains the HTML, it contains the PHP, and also the ASP. Then you can see here that the table contain more than one value in only one tuple, which is the repetition, or you can see these values are not atomic. Then you can see after coming into the first normal form. First normal form means to remove the repetition of the values, to do all the values in the atomic. For example, programming may contain Java, programming may C++, web may contain the HTML, web may contain the PHP, or web may contain the ASP. So this is now easy to search it, because every value, every cell, every tuple have unique value as single value. What is the second normal form? Second normal form discuss the functional dependencies. Here you can see that the student ID is determines student name, okay, but the project name is determined by the project ID, and project ID may be determined by the student ID. So we can determine the student name, project name by the student ID, but we can see that these are partially dependent on the student ID, because the student name depends on the student ID and project name depend on the project ID. So to enter into the second normal form, the first condition is that you must be in first normal form, and secondly there should be no partial dependency. So how we can remove the partial dependency? We may break this table into two tables, as you can see. Now the student contain the student ID, student name, and project ID, where the project ID, here you can see that it becomes the primary key for any project and also the foreign key in the student ID. In the third normal form, transitive dependency exists in the third normal form. As you can see that student ID determine the zip ID and zip ID determine the city. Okay, it is just like a situation that X determined Y and Y determined Z. It is just like such a situation, so it is not allowed in the third normal form. So the condition for the third normal form is that your table must be in the second normal form, and also there should be no transitive dependency in your tables. So we can remove it by creating a second table, and you can see that the transitive dependency is removed here. Okay, the transitive dependency is removed here because student ID determine the Y, the student name, and also determine the zip ID, and here in the second table zip is determining the city. By coded normal form, it is actually the extension of the third normal form, and the one condition is that, for example, X is determined A, then X must be super key. Okay, X must be super key. You have already studied about, we have already discussed in our previous videos that the super key is any key or the combination of key which may be used to determine the other attributes. So if X is going to determine the A, then X must be super key. Okay, for example, in this condition you can say that student ID is a super key, and in this condition you can say that the zip ID is a super key. Different types of joins in the database management system or joins are actually used to get data from different relations, from different tables, or to combine different type of data from different type of table into one table. So the joins are the inner joins. Okay, these are the inner joins and also the outer joins. The first one is inner join, which is the theta join. Theta join applies different type of condition onto tables. These condition may be greater than or equal to or less than or equal to. And for example, this is one table with us, which is mobile, and these attributes are the mobile model and the mobile prices. We have the second table with the name laptop, and the attributes of the laptop is the model and also the price. Okay, and now we are going to apply the conditions that we should show all those data from the table A and B, from the table mobile and laptop, where mobile prices are lower than the laptop prices. As you can see that the first one, this assets prices is lower than from the asset. Okay, so you can see after showing the result of the theta, all these results are populated from the both tables where the prices of the mobile is low from the laptop prices. The second one is the equigen. Equigen equally get the data from the both of the tables and the equality operator. It shows all the data. For example, we have the one table with courses. Okay, the courses ID, the course, and also the department of the course. Okay, database is the CS department, and the mechanics is the mechanical, and it is electrical engineering course. Okay, now we have the second table where the computer science department HOD is A, Mr. A, and the mechanical engineering department HOD is Mr. B, and electrical engineering HOD is Mr. C. So how we can combine this by using the equigen, that you can see that all the data is populated and showed here that the CS department HOD is A. The HOD data is taken from the second table. Mechanical engineering HOD is Mr. B, and electrical engineering HOD is Mr. C. The natural gen, it gets the data from the both table and any particular common attributes. For example, here is the employment. One table implies one table, and the second table is the department, and the common attribute is the department name and also the department name. So this is the common attribute between the table A and table B. So the natural gen of this will be that all the data related to the first one, all the department names are shown here in the front of the first tables. Okay, so the outer gens are the one is the left outer gen. It actually take the data from the second table, from the right table, according to the left table. We have one table which is with the name of country, and it has some data, and the second table is the state. Okay, for example, India, and India country ID is 1, as you can see that is the 1 and 1, and the state are Karnataka and Tamil Nadu, etc. For Pakistan 2, and Pakistan is also Islamabad, but you can see that Nepal country ID is not listed here. But the left gen will get the data according to the left table. Okay, so all the data related to the left table will be shown, but it will not consider the second one. It will just get the data for the left table. As you can see that in this table it combines the data from the both table, and table takes the data from the first, and according to that the data is shown here. Okay, and from those values are null here in the state, but because the Nepal was listed in the left table, so this value is listed here too. And if we take it as a right join, then Nepal will not be enlisted here, because Nepal is in the left country, in the left table. In the right joining, all the data from the right table which matches with the left one will be shown. In the right join, for example, you can say this is the same table and this is the same table of the state, and here you can see that Nepal is not listed here because it is not in the first table. But the Bangladesh and Bangladesh is enlisted in the second table on the right table, so Bangladesh is also listed here, but the Nepal is not listed here. In the first example, in the left, you can you notice that the Nepal was listed but Bangladesh was not listed, because this example was the left join and this is the right join. Full join will combine the data from the both table, and for example, Bangladesh is here, but Bangladesh is not listed here, so it will also be taken. Nepal is shown here, but Nepal is not shown here in the state table. But because we are going to use the full join, so the data will from the both table will be shown here. As you can see, the data from the both tables are taken and shown here on the third table. So this was all about the normalizations, the different type of joins, etc. Okay, thank you so much for watching.